Okay guys, we are going to do an example problem together. So I would like you to pull this worksheet out. Hopefully you've gotten it by now, called Colligative Properties Worksheet Homework. And I'm not going to do these first few, but I am going to do this question right here with you. And then you're going to work on the rest of it together in class. So it first says, what is the new boiling point and freezing point of water when there's 35 grams of potassium chloride, which is KCl, and it's added to 200 grams of water? So the first thing we need to do is figure out which one is the solvent and which one is the solute. All right, the solute is the one that's less. So this is the solute. And so that makes this the solvent. Okay. And once we do that, we'll be able to figure out what to do on the other things. I'm going to go ahead and write the formulas. So for boiling point, you're going to need the delta T sub B, which is the change in the boiling point. This delta sign means change, not range or anything else. That means the change in the boiling point is going to equal the, the I value. Let me erase this. The I value times the K sub B, which is the boiling point constant, times little m, which is molality. And the freezing point one would be delta T sub F, which means the change in the freezing point, equals a negative I, K sub F, and molality, little m. All right, so in order to solve this problem, we got to make sure we fill those in. So the first thing I want you to do is let's go find the K sub B value and the K sub F value. And those are on charts. So I'm going to minimize this for a minute. And this is the chart, the reference chart you should have gotten. Okay. Let's look at this one a little bit better. Now, you'll see over here, this K sub B, the delta T sub B has a K sub B value. In the freezing point, the molal freezing and boiling point constant chart is right here. The first column, notice the first column is the freezing point, and that's in degrees Celsius. And you need to be able to look at that. Now we're doing water today, which is the very bottom one, but we're going to do phenol and octane and other things later. And I don't know those, so I use this chart to find the freezing point. The second column is the K sub F, and so if you can't read that, write K sub F in bigger letters right above it. And the unit is degrees Celsius over molal, which is the little m. And that's the values for that constant. And so the next one is the boiling point in degrees Celsius. And we know it's for water, it's 180, but like when we do phenol, we'll have to go look it up. It's 182.0. And this one is the K sub B. Again, if you can't read K sub B, write that on your chart, K sub B. So I need the K sub F and the K sub B for water. So water, the K sub F is the second column. And you go down the bottom, it's 1.86, and it's degrees Celsius. So I'm going to pull this back up. So the K sub F is 1.86 degrees Celsius divided by little m, which stands for molal. And the K sub B, let's go back to the chart now, is, you go down to the bottom, there's the K sub B in the fourth column, you go down to the bottom, so it's water. It's 0.512. All right, so let's scroll back down here. This is 0.512 degrees Celsius over molality. These things right here you find for the solvent. So that's one reason it's important to know which one is which. Now the I value you find for the solute. So this is the solute, and I have to determine, is it ionic or is it covalent? Well, remember, metal, non-metal, ionic. So potassium is in the first column. So this is a metal and this is a non-metal. So we're talking about an ionic solid here, that we're dissolving. And so when you have an ionic, you have to count the particles. If it's covalent, the I value is always 1. So covalent, I is always equal to 1. That's the particle count. With ionic, you got to see how many parts it falls apart into. So this turns into 1 potassium and 1 chlorine. So the I value here, that's 2 separate things. So the I value is a 2 because of these 2 things. So remember, the I values come from the solute, and the case of B and case of F come from the solvent. All right, now let's work on the problem a little bit more. So what can we fill in? We're trying to figure out the delta T sub B, the change in the boiling point, because then I can get to the new boiling point. It's really asking for the new boiling point, and the new freezing point. And you can change those letters in your formulas if you want to. So, but to get to the new boiling point, I need to know how much it changes. So I'm going to fill in what I know. I know the I value is a 2. I found the K sub B right here. So that's 0.512 degrees Celsius over molal. So now I need the molality, and I don't know that yet. For the delta T sub F, I can fill it in. It's a negative 2 because of the I. And the K sub F is right here. We just wrote it out. 1.86 degrees Celsius over molality. And again, I need to know the molality. So we're going to have to calculate that out. I'm going to do a different color now. So molality is moles of solute over kilograms of solvent. So I know the kilograms of solvent because the solvent is water. Well, no, I don't, because I have it in grams. So that means I have to convert, and you have to show the conversion somewhere on your chart or in your math. So I'm going to do the conversion right here. We have 200 grams. So 1 kilogram is 1,000 grams. Remember that conversion. We're going to cancel out our units. Grams cancel with grams. You need to write this down, the conversion. You got to show the conversion. And so this ends up being 0.200 kilograms. It has to have 3 sig figs because this has a decimal that has 3 sig figs. So the kilograms is 0.200 kilograms. Now I need to know the moles of the solute, and I don't have that. I have grams of solute. So I'm going to have to turn the grams to moles. So that means I'm going to need the molar mass of potassium iodide. So that's why I gave you that right here. What the molar mass of potassium chloride. All right, so potassium, there's only one atom of each. So that's 39.10 for the potassium, and chlorine is 35.45. So if I add those together, I get 0.55, and then a 4. Carry the 1, 74.55 grams over moles. So there's my molar mass, and so I use my molar mass to turn my grams into moles. So I've got 35 grams, so 35.0 grams. I use my molar mass again, 1 mole on the top, 74.55 grams on the bottom. And then we're going to do the math. And let me do that real quick. I'm not going to pull up my calculator this time just because I haven't done it in a long time. So I'm just going to do this right here. So what I do, I'd say 35 divided by 74.55. I get 0.4694. Then I look over there. There's 3 sig figs. So I need 3. So it's 0.469. 0.469 moles. 0.469 moles. 0.469 moles. That number is put right here. Now I'm going to divide both of those and I'll know the molality. 0.469 divided by 0.2. The molality is 2.345. And then I look at the sig figs. I need 3 sig figs because there's 3 sig figs here and here. So this is 2.35 little m, molal. That's what goes in that spot. That m is molality, so that's what goes here. Notice the decimal. It goes over here too. All right, now I can do the math and I can figure out delta T sub B. All right, so the change in the boiling point is going to be, now notice the molal unit and the molal unit cancel. So delta degrees Celsius is left, and that's what temperature is anyway. So 2 times 0.512 and times 2.35, I get 2.406. And then I look at significant figures. You always got to do sig figs each part. So there's 3 sig figs in this number. This number doesn't count for sig figs because I'm just adding things up, like 12 eggs, like just 12. Doesn't have significant figures. This came off a chart, so it doesn't have significant figures. Only the molality will. So I'm going to round that to 3 sig figs, so it'll be 2.41. That's the change in the degrees Celsius, because that's the unit I didn't lose. That's only the change in the boiling point. That's not the new boiling point. So I got to calculate the new boiling point. So the change in the boiling point is also equal to the new boiling point minus the old or the original boiling point. On your chart it just says N minus O. You can change it to look like this. Okay, so now I'm going to take this value, which is the change in the boiling point, and I put it right there in the formula. So 2.41 degrees Celsius equals the new boiling point minus the original boiling point. I get that off that reference chart. So I'll pull the reference chart back up. The boiling point is this third column right here. Go down the bottom. The boiling point is 100.0 for water. Okay, so let's pull this one back up. We're going to pull it back down here. So this is 100.0 degrees Celsius. Now we're just going to isolate the variable by adding to both sides 100. This goes away so that the new boiling point is going to be equal to this. And so that's 102.41. When you add, you use addition significant figures. This ends in the hundredths place, so this has to also end in the hundredths place. This one you got off the chart, it doesn't have significant figures. So the new boiling point then is 102.41 degrees Celsius. Remember that the boiling point should go up and the freezing point should go down. Okay, we'll do an antifreeze lab next week that will help with this as well. Now we're going to calculate the freezing point portion of it. Okay, so the change in the freezing point, don't forget the negative sign right here. So it's going to be a negative 2 times 1.86 times 2.35, and so we get a negative, hold on, 2 times 1.86 times 2.35. Yeah, we get a negative 8.554. And then look at sig figs. This has 3, so a negative 8.55 degrees Celsius. I'm going to check my math one more time, because I don't trust myself on this one. Yeah, I did it. I got a different number. 2 times 1.86 times 2.35. Yeah, this is, sorry, that's not, this is wrong. It's negative 8.742, and that rounds to negative 8.74 degrees Celsius. So that's the change in the freezing point. Now I'm going to need the new freezing point. So I go back to the chart, and I'm going to show you the chart again. Look right at the top. Here are the formulas. So here, right over here, where it says delta T sub B, you could put NB minus OB if you want. And right there, where it says delta T sub F, you could put NF minus OF if you want. So that's okay. I don't mind if you write that on there. All right, let's go back to our worksheet. So now I'm going to write the formula. Here we go. Delta T sub F equals the new freezing point minus the original freezing point. And so I take the value I calculated and put it in that spot, because that's what this is. Negative 8.74 degrees Celsius is the new freezing point. The original freezing point of water is 0.0 degrees Celsius. If we were doing another thing like phenol, you would not have a 0 there. It's only because this is water. Okay? Now we just add 0 to both sides so that the new freezing point is a negative 8.74. So the freezing point did go down. So this is how you calculate these questions. Please make sure you fill all this in carefully. And now you're going to work the rest of this worksheet in class. You can start at the top if you'd like, but I would highly suggest when you're doing your 4x6 card that you put one of these kinds of problems on that card that you can use for the test. Okay, I think that's it, so I'll see you soon.